My name is Noah Nichols, and today we're going to discuss Aeolian features on Mars. To start, we must first take a look at what causes Aeolian features to form. On Mars, the seasonal polar caps are composed of dry ice, or carbon dioxide ice. In the springtime, they will begin to sublimate once the sunlight hits the surface of the ice slab. In other words, the carbon dioxide underneath the surface of the slab goes from a solid straight to a gas. As more and more gas forms, this will cause erosion on the surface of the carbon dioxide ice slab. Eventually, the pressure will build up so much that a crack will form that releases the gas as a carbon dioxide jet. When these jets form, there are particles which are blown upwards from the polar caps by the rush of carbon dioxide. The particles will then create the Aeolian features that we are looking for. In this drawing, you can see that the wind is blowing to the right. This wind blows the particles to the right and creates a fan on the surface of the carbon dioxide slab. Since this is the case, scientists can use these fans to determine the wind direction on Mars. Scientists can also measure the speed at which the wind on Mars is blowing. By measuring the length of the fan, scientists can estimate this wind speed. Shorter fans tend to mean that the wind is less vigorous, while longer fans mean that the wind is blowing more quickly. It is for these reasons that the fan is considered a very useful Aeolian feature. To demonstrate how fans form, I created a model to show how the particles from the carbon dioxide jet would move. To do this, I have utilized a plastic bottle, some dry ice, and warm water. Once the warm water is poured on the dry ice, the movement of the gas becomes clear to see. The lid is then screwed back onto the bottle in order to create the carbon dioxide jet. In this example, we can clearly see that a fan would form. In the next case, an even larger, longer fan would form. In this case, there is very little wind movement. A blotch is likely to form. Though it was drawn earlier, the blotch was not mentioned until now. Blotches are the second Aeolian feature which can form from carbon dioxide jets, but only when no wind is blowing. With no wind, the particles settle in an oval shape. When wind is present, they are carried further away, forming a fan where one end appears to be stretched out in one direction. To help you visualize fans and wind direction, I devised two ways to manipulate the flow of gas. A handheld fan can be used to create wind movement in a particular direction. This can also be accomplished by covering a part of the bottle's opening as well. To me, the best way to cement our understanding of fans and blotches is to take a look at the real images provided by Planet 4. Before doing that, I feel that it is important to describe how these images are acquired by Planet 4. Using the high-rise camera, we are able to see the jets and blotches which form on the surface. This allows us to see the pictures which can be used to determine wind speed and direction. As you can see, citizen scientists can analyze these images to help the lead scientists find out about the wind patterns as a whole on Mars. Using these images, let's take a chance to summarize what we've learned. In this image, the fans are predominantly moving to the left. We know this because the fans are extending in that direction. This means that the wind is moving in that direction as well. In this image, we can see that the wind must be moving down and to the right. We know this because the fans are extending in that direction. These fans are also relatively long, indicating that the winds were quite fast. As one last learning opportunity, try one on your own. Which way is the wind blowing in this image? If you predicted it was upwards and to the right, excellent job. To close, this video would not have been possible without the information from both NASA and Planet 4. Additionally, without the help of Alexis Hart and Carrie Nichols, this video would not have come together in the same manner at all. All in all, I hope you learned a great deal about both the beauty and scientific utility of Aeolian features on Mars. Thanks for watching.